Hi, this is Professor Evans. This video is for COP 1000C, which is Intro to Programming Concepts at Valencia College in Orlando, Florida. This video is going to do some programming examples covering Unit 6, which is User-Defined Functions. Some of the learning objectives for this unit will be that you will learn how to describe predefined and user-defined functions, identify value-returning functions, including actual and formal parameters, construct and use a value-returning user-defined function in a program, identify function prototypes, use void functions in a program, distinguish between value and reference parameters, and compare and contrast local and global identifiers. I'm going to do two programming examples today, which are going to identify the basic elements of creating a user-defined function and then how we call that function within a program. So I'm going to switch over to my compiler here and discuss the first program objective for example 1. So in this program, we're going to ask the user to enter two numbers and calculate the sum, use a function to collect the input from the user, and a function to calculate the sum. So this is our program objective. Our inputs are going to be two integers, num1 and num2. We could also make these double or float. The type of number here is not important, but I'm just going to go with integer for now. And then our output is going to be an integer called sum. So for our process, we need to declare two functions. All right, so function 1, its purpose is going to be to collect a number from the user. That's the purpose of this particular user-defined function. So when we write a function, we have to begin with the first word that describes the return value of the function. So if you think about writing a function, it's a piece of code that you can easily repeat over and over and over to perform a specific objective. In this case, I want a function that's going to collect a number from the user. That means it's going to ask the user for a number and receive the number from the user. A function has what we call a return value, which means that after that function or that piece of code runs, it's going to return a value to the main program. In this case, our function is going to collect a number from the user and return that value to the main program. I know I'm going to be collecting integers, so the return type for my function is also going to be int. I'm going to give the function a name. I'm going to call it getNum. And then inside of these parentheses are the function parameters. The parameters are going to be names of variables, and they're going to represent values that are going to be passed into the function if they were required for some calculation that the function is going to do. In this case, I don't have any parameters that are going to be passed in because I don't have any data that I've collected yet. I'm literally using this function to collect a number from the user. There are no parameters to pass in. So the parameter list is going to be empty here. So I just have getNum, open parenthesis, close parenthesis. And I'll add a comment that no parameters are required and that it returns an integer. So when we declare this function right here, that's the information we can gain just from looking at this line right here. Our second function is going to calculate the sum of two numbers. Since I know that my sum should be an integer as well, my return value is going to be int. I'm going to call this function calcsum. And in this case, I know that I am going to need to send the function the two numbers that I want to calculate the sum of. So I'm going to have some parameters in this case. I'm going to have two numbers that I'm going to call n1 and n2. So n1 and n2 represent two integer values that will be passed into the function. And then within the function, I'll calculate the sum and return it as an integer to the main program. Okay, so we have two integers are the parameters, and it's going to return an integer. And we know that that integer is going to represent the sum of the two input parameters. All right, so we're going to create a function called getNum. We're going to create a function called calcsum. We're going to call those functions within our main program. And then after we collect the numbers and calculate the sum, we're going to print the output sum to the user. So this is going to be our process for this particular program objective. Now, just before my main program, I am going to declare the functions I intend to use within the program. That's going to be getNum and calcsum. So before the main program begins, I need to declare my functions right up here at the top after my using namespace statement. Now, my main program is going to go right down here. And then after my main program, I'm going to go ahead and write my functions. So I'm going to come back to the main program in a little bit. Right now, I'm going to declare what getNum is going to do and what calcsum is going to do. So I'm going to write the code for my two functions right down here. So I'm going to begin with int getNum. Okay, so this is where we implement an algorithm to accomplish the function's task. If we remember from up top, the purpose of function 1 is to collect a number from the user and return it to the main program. So I'm going to put my little comment right here to remind me of what getNum is supposed to do. So in order to collect a number from the user, I need a cout statement. Now, I need to get the number from the user and store that in a variable. Well, I don't have a variable to store that in right now. I need to declare a variable to store that in right now. So I'm going to declare a new variable. I'm just going to call it x. You could give it, give it a name. And just keep in mind that once you declare a variable inside of a function, it's only visible within that function. I cannot go into my main program and try to print x, add something to x, store x in another variable. X only exists within this function. So now that I have a variable x, I'm going to store the user's number in x. And then I'm going to return x. This line right here sends the value of x back to the main program. So when we say int getNum right here, that's the return value. So we have to make sure that whatever we return right here matches the same type. So if this is supposed to return an integer, x has to be declared as an integer so that when we return it, the types match. So there's our function getNum that's going to get a number from the user and return that value to the main program. Now I'm going to write our second function. I'll say this is function number 1. Body goes here. Okay, so function 2 will go here. Our second function was int calc sum, where we're passing in n1 and n2. Now, when I say passing in, what I mean is that when we call this function in the main program, we're going to send calc sum 2 values. Those 2 values are going to be integers. Within my function, those 2 integers will be called n1 and n2. Again, the numbers n1 and n2 are what the function will refer to our inputs as. So I might pass in a 5 and an 8. Well, 5 is going to become n1 and 8 is going to become n2. And I can reference n1 and n2 anywhere within the function. But n1 and n2 do not exist in my main program. These only exist in my function. Now, I can't use this function unless I pass in 2 integers. Everything that I pass in must match the type as defined here. And since this calls for 2 integers, I have to give it 2 integers. Otherwise, I'm going to get an error when I try to call this function from the main program. Now, calc sum's purpose is to calculate the sum of 2 numbers. So let's go ahead and copy that down so we can make sure we focus on what this function is supposed to do. Calculate the sum of 2 numbers. So I need a variable to store the sum. I'm going to call it the sum. I'm not going to call it sum because I've already determined that in my main program, I'm going to use sum for the main program. So I'm going to give this a different name. I'm going to call it the sum. And we know that the sum has to be equal to the 2 values being sent in as parameters. I need to take n1 and n2 and add them together. Once I do that, I need to return the sum to the main program. So just like return x up here returns the user's number back to the main program, this is going to send the value of the sum back to the main program. So these are my 2 functions. Now that I have 2 functions written, I can go to my main program and call these functions to collect 2 numbers and then to add them together. So in my main function, I'm going to define my variables. If we go back up here, we decided we're going to have 2 inputs, num1 and num2, one output called sum. So I'm going to define those right here. All right, next we need to collect the numbers from the user using our function getNum. So we're going to say num1 equals getNum. So when this line executes, the function getNum will automatically begin to run. So these lines of code will execute next. So an integer x will be created, a message will be displayed, that user will enter a number and it'll be stored in x, and x will be returned, and the value of x goes right into num1. Now I can call this function as many times as I'd like to get as many numbers as I'd like. So num2 is going to call the same function. That means this code is going to run again. But this time, x will be replaced with a new value for whatever the user enters in the second time. So each time I run this, it's like running a new copy of this code where x will become whatever value the user enters when this particular line is executed, when that particular function call is executed. So this is how I'm going to use that function to get 2 numbers from the user. Once I've done that, I'm going to calculate the sum using our function calcsum. So we know that sum has to be equal to, and here's where we're going to call our function calcsum. And remember, because calcsum is defined with 2 integers as parameters, I have to give it 2 integers right here, which is going to be num1 and num2. So those 2 numbers that we took in from the user are going to be passed in to calcsum. So calcsum is going to run. Num1 is going to be passed into n1. And anywhere that we see n1 within the function, that n1 is going to be the value of whatever num1 was when we passed it in. Num2 is going to be passed into n2, and everywhere that we see n2 within our function, we know that that value is going to be whatever num2 was. The sum that gets returned is going to be stored right here in sum. And that's how we're going to calculate the sum using our function. Once we're done, we're going to print the output. And then we're going to end the program. So there's our code for example 1. Let's go ahead and open up the console here and check for any errors. Okay, it compiled. So I'm going to enter a number, 109 and -10. And then we can see the sum of 109 and -10 is 99. I misspelled sum. I'll take that out and run it one more time. So I'm going to enter a number, 560 and 220, and we can see the sum is 780. So this is a very oversimplified example of functions, just so that you can get an idea of how we construct a function down here, and then how we call the function in our main program. So that concludes example number 1. Now I'm going to move on to example number 2. All right, so I have our second example on the screen. I went ahead and typed out the program objective first because this one has a little bit of a longer process. So just to sort of jump start, I went ahead and put the program objective on the screen. So for this example, we're going to write a program that prompts the user to enter the center and a point on a circle. So we have 2 coordinates. The center is going to be represented by x1, y1, and a point is going to be represented by x2, y2. So if you think about the coordinate plane, we have the x-axis and the y-axis. We're going to have a circle on that coordinate plane. The center of the circle will be represented by the point x1, y1, and then a certain point on that circle will be represented by x2, y2. The program should output the circle's radius, diameter, circumference, and area. So the following formula gives the distance between 2 points, x1, y1, and x2, y2 in the Cartesian plane. So this formula right here can give us the distance between any 2 points. You take the square root of the quantity x squared minus x2 squared minus x1 squared plus y2 squared minus y1 squared. If you use this formula, given the center and a point on the circle, then you can use that to find the radius of the circle. So our inputs for this particular program are going to be our 4 coordinates, x1, y1, x2, y2, 2 coordinate pairs. Our outputs are going to be the radius, diameter, circumference, and area. Now let's talk about the process. For this program, we're going to define 4 functions, 1 function for each output that we want to generate. So let's start with function 1. We're going to start by defining a function for the radius. So this function we'll find the radius of a circle given the center of the circle and a point on the circle. All right, so for this function, we're going to give it a return type of double because our inputs are going to be doubles. So we're going to have a return type of double. We're going to call it radius as its name. And then we're going to pass in x1, y1, x2, and y2. But we're not going to use these names because if we use these names, we're already using these for our main program. We don't want to repeat these names within our function. That could become confusing, and it doesn't help you understand the idea of global variables versus local variables. So we're going to make sure that we change the name here. Well, we can use something very similar. So I'm going to say that we're going to pass in, we're going to call this first x, and then double first y, double second x, double second y. So that'll represent our x1, y1, x2, y2. So we're going to pass that in. And in this case, we want to be able to use this distance formula to actually calculate our radius. So let's create a double called distance. And distance is going to be equal to all right, so we're going to say distance is going to be equal to the square root of, and then we're going to use the power function here. And we're going to have some arguments. So within our power function, we're going to say second x minus first x comma 2. So we want to take the second x minus the first x, raise it to a power of 2. And then within our square root, we also want to do the same thing for y. All right, so next, so let me look at our parentheses here. So make sure you can see this parenthesis lines up with this one. This parenthesis lines up with our power function. And this parenthesis lines up with our expression that we want to raise to a power. So I'm going to do plus, and now I'm going to repeat this for y. All right. So I'm going to double check my parentheses here. So our distance formula is the square root of, we have a parentheses, then we have power, 2 parentheses, second x minus first x, close parentheses, comma, 2. Forgot my 2 right there. And then we have plus power, 2 parentheses, second y, minus first y, close parentheses, comma, 2, close, close. This function right here is going to give us the radius, and then we're going to return distance. So by calculating the distance between these 2 points, we're effectively calculating the radius of the circle. Our second function that we're going to want to define is circumference. All right, so with this function, we want to find the circumference of a circle. As long as we give the radius. All right. So in this function, we're also going to call this double circumference. And you know what? I want to point out that if our outputs are going to be radius, diameter, circumference, and area, we don't want to name our functions the same thing. So I'm going to go ahead and name this the radius and the circumference. We'll change that like that. All right, so our circumference is going to take as an input the radius. And just to make sure that we use a different name than what our output is going to do, we'll call this circle radius. Again, the variable names you use in your function, you want to be different than what you're going to use in your main program or any of your function names. All right, so now we're going to calculate the radius. And essentially what we want to do, we know that, we're going to calculate the circumference. We know that the circumference is 2 times pi times radius. That's how we would calculate the circumference of a circle. So in this case, we're going to go ahead and say return, and we can just calculate this all within our return statement. 2 times pi, and we can use 3.14 for pi. We can also decide to define a constant called pi. So if you want to, we can just call that pi, and then in our program, we'll define pi as a constant, so we could do it that way too. I guess I'll go ahead with that second option. Times circle radius. Oops. So in a return statement, we can do a calculation. We don't even have to define a new variable, a local variable within our function. If I know what I want to do and return that value immediately, I can do it all within a return statement. So function 2 is going to return 2 times pi, where we're going to define pi as a global variable in our main program. And then we're going to multiply that by the circle radius that's being passed in. This is going to be a double value that'll be returned as a double value per the return value in our function declaration here. So there's circumference. All right, we're on function 3. We're going to calculate the area of the circle in this function using the radius. So I'm going to call it double the area. All right. This one is also going to take as an input the radius. Now, in this case, I'm going to use the same name I used for circumference because this is local. It only exists within this function. If I declare another variable here for this function called circle radius, it only exists within this function. So because I'm referring to the same value, the radius of the circle, I'm going to go ahead and use this name again. But that's again because this name is only going to be local to this function, not to the entire program. All right, so if we review a little bit of geometry, we know that to calculate the area of a circle, it'd be pi r squared. Pi r squared gives us the area of a circle. So in this case, I'm going to return pi times circle radius times circle radius. And that will give me pi r squared. All right, so we have these functions here. And then our last function is going to be for diameter. So function 4, this function will calculate the diameter of a circle given the radius. All right, so I'm going to call this double the diameter. We're going to pass in double circle radius again. And we're going to return. So the diameter is going to be double the radius. Again, this is all just sort of review from geometry class, but when we figure out the diameter of a circle, we just take the radius and multiply by 2. So I'm going to say return 2 times circle radius. If you notice here as I was typing, this particular compiler tells me that circle radius is local. So again, just trying to drive home the point that within a function, whatever we reference, so circle radius is local to this function. The value of circle radius that exists within function 4 is not going to be the same value that exists in the area or the circumference. So whenever we use a variable within a function, it's local to that function. It's not visible outside of the function itself. The only thing that's visible outside of the function is whatever we end up returning at the end. So we have our 4 functions to give us these 4 outputs: radius, diameter, circumference, and area. And that's really going to make up our process. Basically, we're going to call each one of these functions, and then we are going to print the output. So our process is basically going to be take the input from the user, call each function, print the results. This is what we're going to do with our main program. So we have our 4 functions, what they're going to do, and then we have our main program and what it's going to do. So it's taken a while to set up the problem, but once again, by framing the problem and taking time to think through it and think about each small piece, it's going to make writing your code go a lot faster. I now know what my 4 functions are supposed to do. I now know what my main program is supposed to do. Now I just need to put all of these individual pieces together. So I'm going to start my program now. I'm going to start by including IOStream. I'm also going to include CMath, so I can use the power function and square root functions. I'm going to include IOmanip so that I can round my answers to 2 decimal places. Now I'm going to define a constant here. This constant is global, meaning anywhere in my program it can be seen and used, in any function or in the main program. So I'm going to define a constant double called pi, and I'm going to use 3.1416 for pi. So if you look at the functions that I wrote, everywhere that I called pi, I am actually going to be able to access pi as this global constant double because it's defined before the main program. It is global. So that's the difference between global and local. A local variable is only accessible within the function. A global variable is accessible everywhere, within multiple functions as well as within your main program. Now I'm going to go ahead and declare the functions that I'm going to use. So I know I'm going to have the diameter, the area. I'm going to have the circumference. And I'm going to have the radius. Those are the 4 functions I plan on calling. I have their return types, the name, and the parameters that they're going to take in. So now that I have my function declarations, the next thing I would do is create my main program. But I'm going to leave that for later and put all of my functions down below. If you have a really well-written process, this becomes pretty much a copy and paste effort. Copy, paste, and debug. I'm going to delete my comments here. But there's my 4 functions. So we have diameter, area, circumference, and radius. Now I can go on to my main program, where I am going to declare the inputs. So that's going to be x1, y1, x2, y2. And I'm going to declare my outputs. Once again, if I have this well written up here in my process, I can copy and paste. All right, so now I'm going to do a function call. Well, actually, before I do my function call, I need to collect the input from the user. So I'm going to do that first. If I wanted to, I could also turn the collection of data from the user into a function as well. Okay, so there's x1 and y1. Then we're going to ask for the x and y coordinates of the point on the circle and grab x2 and y2. Now we can go ahead and calculate our 4 outputs. So radius equals, I'm going to call my function the radius, and I'm going to pass in x1, y1, x2, y2. I'm going to make sure that x1 lines up with first x, y1 lines up with first y. They have to go in the exact same order. If I change the order from how I defined this, then I'm not going to get the right answer. So for example, we don't want to put x1, x2, y1, y2 here. If you intended for x1 to be first, you have to call it first here. If you intended for y1 to be second, it must be second here. Everything in order must match the way that you defined it. So there's our radius. Next, we're going to calculate diameter. All right, and the diameter just needs the radius. So I'm going to pass in radius. So once I calculate the radius here, that becomes the value that I can pass in to diameter, circumference, and area. So I have to calculate radius first because I need that value for the other 3 functions. So I can now call circumference. And I can call the area. And now I can print my data to the user. All right, so I'm ready now to start debugging. All right, let's take a look at our errors. Okay, looks like I spelled iomanip wrong. Let's fix it. Okay, we fixed our syntax errors. Now let's make sure that we don't have any logic errors. So enter the x and y coordinates of the center of the circle. Let's say that the center of the circle is at 0, 0. And let's say that the x and y coordinates of a point on the circle are, let's make it simple, we'll say 4, 4. And here's our output. So let's go ahead and make sure that this is right. If you grab a calculator and type in the 2 points that we entered into our formula for distance, and coincidentally, which is also the radius in this case, you will see that you should get that the radius is about 5.66. We know that the diameter should be double that, which it is. The circumference should be 2 pi times the radius, which it is. And the area should be pi times the radius squared. So all of these values come out correct. If you happen to see that these values were not correct, you would have a logic error, and at that point you'd have to go back into your functions and determine if perhaps your math was wrong or if you used a function incorrectly. So in this case, we can see that our output is verified and that all 4 of our values are what we expected them to be. I will say I noticed a small typo here when I typed in the formula. The exponent goes outside of these parentheses, not inside. Like that, but this is how we typed in our equation down here. I just accidentally put the exponents in the wrong spots for the formula. All right, so that concludes our second example using functions. As always, if you have any questions, please send me an email or a Canvas message. Thanks for watching. See you next time.